Good morning, I'm Dr. Schroyer, and welcome to Topic 1, Homeostasis, and Part 1. Today we're going to talk about homeostasis, the normal range, the mole concept, and the atom concept for sodium. So let's get started. Number 1, homeostasis. Homeostasis, the concept, homeo means like, stasis means steady. So homeostasis means the steady state. The steady state is the normal physiologic conditions of the human body. That is the normal state of the human body. 2, normal range. It's a concept in medicine or in any other science. This is the range in which a constituent is considered normal. On an XY graph, two-dimensional graph, the range is the Y value. In the case of sodium concentration in blood, it is 135 to 145 milliequivalents per liter. This is a concentration. I'll explain these units in a second. 135 to 145. So you can see somewhere in the middle is the mean, where 50% of the people would have a value of approximately 140 milliequivalents per liter. So where do we get the range from? Well, it's a statistical concept. This is a two-dimensional graph, statistical, with the sodium values at the x-axis and the probability frequency on the y-axis. Probability frequency goes from 0 to 1, which is basically 1 is 100% of the population and 0 is 0%. So this is probability. And the mean value is here, somewhere in here. This is considered the normal value of approximately 140 milliequivalents per liter. On both sides of the mean is your standard deviations of 1, 2, 3 in the minus direction, and 1, 2, 3 in the positive direction. Standard deviation is a math concept which says how does it deviate from the mean? How far from the mean? Right here at minus 3 and 3 is your 135 at minus 3 and your 145 at plus 3. This is considered the Gaussian distribution or the normal distribution or the bell curve because it looks like a bell. So this is population statistics. This is an X number, large value of people that have been studied who were considered normal, and it had and developed this range of 3 standard deviations. Most people are in here. If you're out here or over here, you're in an abnormal range, non-physiologic, possibly a disease or an abnormal state. The area under the curve is a percentage of people, 100% of the people. In the one standard deviation on each side of the curve has an area of about 68%. 2 standard deviations, area under the curve is 95%, and 3 is 99%. So you can see that if you're not part of the 100% of people in this normal range, if you're 125 milliequivalents of sodium, you're in an abnormal range and you're possibly in a life-threatening low sodium state. Okay. Now let's talk about the units. Mole, which is designated as little n, is the amount of material. So it's a weight. And equivalent is the amount of a charge, which is signified as low Q. Now, the mole and the equivalent, when it comes to sodium, is considered equal. The milli means 1 over 1,000, and it's in 1 liter of solvent, water. Okay? Now, the mole comes from the concept of grams per molecular weight. So, you go to the periodic table, and in the first column, third row of the periodic table, you see this. You see 11, symbol of sodium, and the molecular weight, 22.99. This means 11 means it's 11 protons, and therefore to have sodium in a neutral, uncharged state, which is sodium to the 0, formal charge of 0, means there's 11 electrons. Protons match electrons. This is the element sodium, and this is the molecular weight. So, any amount of grams that equal 22.99 grams, you have 1 mole. So the molecular weight, 22.99, and the amount of grams. Okay? Now remember, the mole, in this case, is equal to the equivalence. And this is a charge concept. So let's explain the charge. Sodium in the 0 state loses an electron and becomes a +1 formal state, formal charge, loss of an electron. Okay? This is the charge. This is the charge concept. It is a 1 charge to 1 sodium. So with sodium in the ionic state of a +1 formal charge has 1 charge. So the same amount of material of sodium +1 is the same charge amount of 1. So it's a 1 equals 1 equivalency. Okay? Now, the atom, the sodium atom in the outer shell, the valence shell, has a 1 electron in the outer valence shell of sodium. This means that this is the reactive shell. So this can gain electrons, this can lose electrons. Now, in the case of sodium, it is much easier to lose the electron and become a +1 formal charge and become stabilized and have the electronic configuration of neon, a noble gas, which is totally stable and non-reactive. So it prefers to be in a stable state. So this is, believe it or not, this is an unstable state. So in a reaction mechanism, sodium tends to lose the electron and become an ion. Okay, now in water, we'll explain this more later, but this is valuable in water, and this is how sodium is found in water, in the ionic state. This is why sodium is considered an alkali metal, because sodium is lose an electron. A base tends to lose an electron. That's why the concept alkali, base, and metal, because sodium is a metal. Okay, so in summary, homeostasis, normal range, concept of the units, and the concept of the sodium atom. I'll see you next time for part 2 of homeostasis.